And we are off. Okay. So this is where we left off. We have our canvas, we have our buttons that kind of, do they actually do anything anymore? I don't know. But we kind of looked at how to, the A button does something, it logs something out to the console. We were looking at object-oriented programming. We've got a class called Square. We are creating instances of the class Square. We've got some kind of optional parameters being passed through, so we can have some variations. We've got our update loop. So, Damien, you have basically done a boot camp. Michael, can you give me some indication of your experience level? If it's 0, then that's fine. That will just slightly sway how much I explain as we go along. Maximo Lanza, again, a name.
No, along with Damien, I did a boot camp, but I've been doing JavaScript for quite some time.
Okay.
Like 5+ years, but got brought up to 2021 level.
Yeah, okay, cool. Maximo Lanza, I don't recognize your name from last week, so apologize if you were here last week. Welcome. It's a 2-parter, so if you weren't here last week, there's some catching up to do. I've posted a link. You can see this link. You can get a fork. But okay, we're now getting latecomers. Okay, and I know some of these latecomers are possibly slightly newer than you two. So Maria Estella, I don't quite know how much of that name I should read out, but Maria, I'm going to say Maria, welcome. Okay, we've got 2 versions of Maria. That's fine. Anyway, I'm just going to jump right in. I think it seems like some of you have experience, so I won't necessarily explain everything about arrays, for example. Arrays, something we kind of missed off last week, but I'm not going to go back to basics. I'm just going to hopefully make some decent progress. So we want a bunch of squares. So and actually I'm going to call them something slightly different now. I'm going to call them blocks. Remember, we're making Arcanoid. We're making a sort of version of this game. So we're going to make these. We're going to make these, and they're going to be called blocks rather than squares. They're going to be instances of the class Square for now. We might change that a little bit later. But I'm going to call them blocks. So blocks is going to be an empty array. We now want to push into this array a whole bunch of squares. For this, we can have a for loop. So index, I'm going to say x. The reason I'm going to say x instead of index or I there wouldn't really mean anything. Usually when you have a for loop, you call it I or index because that's referring to an index in an array that you are iterating over. In this case, we're going to refer to the kind of x position of a kind of coordinate system. So x0 is going to be over here, then 1, 2, 3, 4, 5. We're going to have 10 blocks across the top here. We'll space them out evenly. We'll see what it looks like. So we're going to have new block is new square. Slightly confusing. X is just going to be x. X, y. Let's just say y is 10. And what's that argument? That argument is speed. So speed is going to be 0, 0, and color, we could actually do some funky stuff with color, but for now, let's just give it all the same color. Let's get rid of these 2 squares as well. Okay, we then, once we have that block, we want to push our new block into our array of blocks. Cool, I'm going to save that, I'm going to reload. We can't see anything. We've created our squares, but we're not updating them or drawing them. So we want to iterate over our array of blocks, and for each block we want to call draw on the individual block itself. So blocks dot for each block we want to call block dot update, and then we want to call block dot draw. Now the reason I'm not just calling update inside here and calling draw immediately, you kind of want to separate the logic for updating all of the sort of behaviors before you draw all of your elements that are on the screen. In update, we might decide, we will in fact later on, in update we might decide to remove this block. Therefore, we don't actually want to draw it when we get round to the drawing phase. So, in fact, I'm going to have draw as a separate function, just to really, and you could kind of update the physics, let's say, you could update the physics at a kind of different rate to the update to drawing to the screen. That's one way to do it. We could have request animation frame for update, so the physics are updating all the time, but we could draw less frequently than the physics, or vice versa. But we're not going to do that. We're going to have update. Oh, in fact, we want that inside our draw function. We want to clear the entire canvas before we then draw all our blocks. That doesn't need to happen before our update, so we'll update all our blocks and then we will draw them. Great, we've got a load of little blocks. I am currently saying x start at 0, then increase by 1 every time until you're 10, and then use exactly that value to set the x position of the blocks. What we want to do is something like block spacing is an object where x is 30, y is 30 as well. Let's see how that works. Block spacing dot x. So we're going to multiply our x, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or just 9. We're going to multiply that by this block spacing value. And now we get nice big gaps between each block. It's a bit funky. We probably kind of want to use the width and the height, and then width plus block spacing, but whatever. So if we now look at the width and height of these squares, which might change later on, is 10, let's say 15. Let's get them a little bit closer together. Oh yes, I have to reload, that's very annoying. And we'll start at 1, we'll go up to 20, let's get a load of these things. Do you reckon it goes off the edge of the screen? Do you reckon there's one? Shall I count? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 19. Okay, so it was perfectly 20, but never mind, 19 will do. So, that's like one row of blocks. We've got this for loop. For every time that x is less than 19, increase x by 1 and create a new block. We've created a row of blocks. Now we want to create multiple rows of blocks, and we're going to do the same thing. So we want a for loop inside our for loop, or a for loop around the outside of this current for loop. So for let y equals 1, let's say that y is less than 5, y plus plus. So now we chuck that inside, and for our y value we say y times block spacing dot y, which is going to be, I don't know, 12. We've got a whole grid of blocks. They're all squares right now. We might try and do things a little bit differently later on with rectangles. In theory, it's relatively straightforward. If I've got block spacing 15, let's say 14 here, in theory it's just a case of doing width like that. Yeah, fine, let's leave it like that. Let's see, how wrong could it go? Okay. Now, a good habit to get into is naming, and naming things sensibly. I now don't like the name of this class called square, so I'm going to change it to block. I'm also going to do something that's not necessarily good practice, and I'm not going to extend the class square for our blocks up here, for our paddle down the bottom, for the square that's going to bounce around. I'm not going to do that, because in theory this workshop is for real beginners. If you're following along and you're not a real beginner, I encourage you to extend the class square to make a block class. Later on, when we make a paddle class that's going to be down here, I'm just going to copy and paste the entire class of square. It's bad practice, but for beginners I don't have to talk about inheritance or anything like that. So I encourage you to use inheritance to extend the class square to each of those three classes. Anyway, so I'm going to change it to block. That's going to say that doesn't exist. Block.js, block.js, block. Okay, we're back at square one. I'm going to copy and paste block. Okay, I can't copy and paste block, so I have to create a new file called paddle, which is kind of like player. This is going to be the thing at the bottom that moves left and right when we click on these buttons, and it's going to be initially a copy of block. Width, I don't know, is going to be 30. Height can be 10, that's fine. Speed, we want to start at 0. In fact, starting position, no, let's leave it like that. Speed, we don't really want. The paddle can determine the color, so I'm going to remove that. Colors dot light. Speed is going to start at 0, 0, because our paddle is just going to sit there in the middle until we press one of our buttons. Width 30, height 10, speed, starting position, yeah, that'll do. Okay, so now we're going to have blocks. Paddle is new paddle, and our starting position, anyone remember how big this is? This is 200 high, so 180. Whoops. X 150, Y 180. Then in draw, we're going to say paddle.draw, and in update, we're going to say paddle.update. Can't see it particularly well, so we're going to say dark or darkest. I don't know what color are the blocks? Are the blocks the same color? Okay, no. So that's now slightly darker. Later on, maybe we'll make these every row a different color or something like that. But for now, let's just make some progress. So we've got our paddle. It's not quite centered. Remember, top left rectangles are kind of defined, are drawn from their top left. So I've just said our paddle is going to be X 150 if it's 300 wide, 150 is the middle, but actually we kind of want it to be at 150 minus half the width of the paddle. If you're following along and you're ahead of me, do that sort of thing kind of while I'm chatting away. But I'm not going to do that. I can't be bothered. So we want to hook up the left and right movement. So inside paddle, we're going to do some user input stuff like we did over here in our user input file. So in paddle, we can add a method called listen for user input, and we can, how much shall I copy? I'll copy, I don't know. So button class left and button class right, those are the two that we want. I think in this game we're not actually going to use either of these, are we? But never mind. Button class left, button class right. So actually up here, left button is document, query selector, exactly the same as last week. We want to find the element with the class of left, and then element with the class of right. Now left button dot add event listener. Click. When we click on that, we want to say this dot speed is 1. This dot speed dot x, is 1. No, left, so we're going that way, so it's -1. And right button to add event listener, click, this speed x is +1. All we need to do is that. Now I suspect we're going to get something funky. It's never going to stop, but because our update function is always just looking at that speed, it's adjusting its position based on the speed. When we actually do our button press, we just need to set the speed to be a new value. So if you're ahead of me, well done. The reason nothing's happening, I've defined this function, but I've not actually called it anywhere. So we can call it in the constructor, this dot listen for user input. We call that function, and then so that'll do. It's probably going to bounce. Yeah, is it going to bounce the other way? Yeah, that's fine. Again, If you're ahead of me, try and do it so it's only on kind of mouse down or something like that. In fact, whatever. Yeah, I'm going to leave it like that. I think that absolutely, if you're following along and you're enjoying yourself, do absolutely feel free to just sort of take this home and make it better. I know the code is not following best practices in some cases. I'm trying to make it beginner friendly. Also, the functionality, like that particular example, is kind of funky, but I think that's quite a nice improvement that you can make in your own version. So I'm going to leave that like that for now. Adrian. Welcome, Adrian. Again, a name that I don't remember from last week. Apologise if I don't remember the name, but if you weren't here last week, there's plenty of catching up to do. But welcome anyway. Okay, so now we kind of want to do the same thing, but for our left and right buttons, because it's easier as a developer. So we're going to do something like this. Oh, whoops. So back in Paddle, listen for user input. That's dealing with our elements, our buttons on the page. But here, add event listener, key down, event key character. So left character. Event key is left character. What's the key when you press left? JS key codes. I use a site that's very useful. I use this all the time. All it does is log out a bunch of stuff, or display to the screen a bunch of stuff whenever you press buttons. Oh, it's made by Wes Boz. That's good. And it's copied to clipboard. Look how great this is. Okay, so event.key gives us this string, arrow left, arrow right. These numbers, these are key codes. Event.which, okay, deprecated, that would make sense. Event.code. Key, interesting, okay. Well, we're going to use arrow left and arrow right. So over in here, left character is arrow left, and right character is arrow right, probably. Yeah, never mind, I'm just going to copy it. So if we're pressing left, then do that, else if event.key is right character, then we're going to do the same thing that we do up here. Again, else if. Again, that's not great practice, really. I don't know, separate that out into some function somewhere and call it. But for sort of speed and ease of understanding, so we want nice. That's much easier for me as a developer. And probably for many players who aren't on phones or things like that. Okay. Now what? Now we need the ball. So the ball, I suppose we could display it as a circle, but I think we'll do that later down the line, depending how we do for time. But for now, it's going to be a copy of block, it's going to be a square, and it's going to bounce around. Much like we had last time, we had a square that was bouncing around, and that's all good. But this time we need a few improvements. So, no, I want it in here. I don't like that. Ball.js is going to be ball. Then in index, we can say ball is new ball. And how about let's pass the paddle. So we're going to pass the paddle so that the ball can know relative to the paddle the position to use as its starting position. It's also got to move with the paddle as well. Well, there's all sorts of things that I haven't thought about yet, but never mind. We'll see how we get on. Okay, ball.draw, ball.update. The order in which these occur kind of does matter. The order in which this occurs also does matter. In this game, doesn't matter so much. But if you've got different layers of foreground, background stuff, that's going to affect your draw order, your update. Also, maybe you want to move the ball to determine if it's hit a block before you update all the blocks. In fact, there's an improvement. We actually don't need to update the blocks anymore because they don't move; they just sit there. So that's a performance improvement we can make. We might add it back later on, depending on what we do with the blocks, but never mind. Okay. Ball is possibly being displayed. Where would it be displayed? Okay, starting position is undefined because, oh no, it's not undefined, kind of. It's actually a paddle. So because I've changed what I'm going to pass in to the constructor, I'm now passing in the paddle. So the ball, which I haven't updated yet, is looking at starting position, which is actually a paddle, and it's saying starting position or paddle.x for this position. So actually these are going to be undefined, so I'm surprised they don't get an error, but it's not able to draw to the screen. That's ultimately what's happening. So let's change paddle, let's set speed again. It doesn't want to do anything yet. So paddle okay, well, height 10, this dot position. Okay, so it's going to be paddle dot. What have we got in paddle? We've got paddle position dot x and paddle position dot y. Colors dot dark. Let's see what it does. Okay. We're drawing the ball at exactly the same start position as our paddle. So again, top left, rectangles all drawn from the top left. So our paddle is like this, and our ball is going, okay, I'm going to place myself at the same position as the paddle, so we draw it there. So what we want to do, remember y is positive going down, so we want to subtract the height of the ball, which luckily for us is just this dot height. And x we want to add, well, we want to add paddle dot width divided by 2, then subtract this dot width divided by 2. I think that looks pretty good, so I'll show you what it was like if if I didn't subtract half the width of the block. So remember, top left. Welcome Vicente. Remember top left, so the kind of 0 position where we're drawing this block is going to be here. So if we want it to look like it's in the middle, we then need to subtract half of the width of the block to get it to look like it's in the middle of the paddle. Okay. Now, I'm going to do welcome Sebastian. I'm going to next make our block start moving when I press A. So I press A or space, and the block is going to start moving at a sort of slight angle, whatever classic Arkanoid is. I realise there is an issue, we might come back to it later, but right now it's not actually connected to the paddle. If we move our paddle, it's going to stay there. Firing the ball is far more important than that, so just for the purposes of today, I'm going to release the ball, fire the ball when you press A. So what we can do on our ball class, we can have a method called fire. This.speed.x is 1, this.speed.y is also -1. We want it to go up, so it's going to go kind of diagonally up and right. So we've got this method called fire. In paddle, we kind of have our ball. Oh, let's do it on the ball. Yeah, that makes sense. And then I can show you remove event listener. So A button, lovely stuff. In ball, welcome Adrian. I think I recognize your avatar at least from last week, so welcome back. Okay, so on the ball, listen for fire button press. We're going to have this function. We're going to get the A button. We're going to do all sorts of stuff. We're going to listen for user input on click. This dot fire. And then, just like we did on the paddle, we need to, in our constructor, we need to call listen for button press. Oh, 4. Listen for button press. We call that in the constructor. This then grabs that button, which can be done out here. It's never going to change. I don't really like doing that in methods down here, but it's not really important. So great. Okay, so it bounces off the walls. It's probably not going to bounce off the paddle. No. And it doesn't bounce off any of the blocks. So this is where things get slightly more complicated. It's still pretty simple as far as like games go, but there's a bit of sort of maths, and it's not particularly friendly. So apologies if you're a beginner. I suspect it might go over your head, or maybe it's just me and I'm stupid and bad at maths. So in our update loop, probably on the ball, we want to say, are we overlapping with any of these blocks? So we move the ball. We then say, are we overlapping with any of the blocks? If we are, we'll kind of reflect back, we'll change the direction of our speed of the ball, and therefore it will bounce. So this is the kind of bounce stuff that we're doing. We're just flipping speed to be speed x, to be minus x, it's minus speed x, same with y. That's what we're going to do for the reflection. So the reflection is not super complicated, but the kind of intersection with two rectangles, I've got to Google it, for example. It's not something that's off the top of my head. So the intersection with the rectangles, and then kind of deciding which direction to reflect in, that's going to be slightly weird, but we'll give it a shot. So in update, we're going to move. I'm going to just separate things out. So we'll have move, and we're going to call this dot move. We are going to say apply screen constraints, and in fact, when we go down here, we want to kind of reload the page or something. We want to show game over. You lose the game, but we'll do that later on. So this dot move, then this dot apply screen constraints, then check for block collision. So this dot check for block collision. Now we need access to all of our blocks. There's a whole bunch of different ways to do this. What I'm going to do is pass it in on update. So we're going to receive our array of blocks in our update function. We're going to pass that along to check for block collision. Check for block collision is then going to have our array of blocks, and then we can do something for every block. We're going to check that they're not intersecting. Let's make sure we set that up on the other end. So in our update function for ball, we're going to pass through our array of blocks that's up here. Like I said, there's a million different ways to do that. You could pass that in the constructor. Yeah, that would sort of work, but for me, this is a kind of neat-ish way to do it. So check for block collision. I now, luckily, have a nice Stack Overflow answer. It's also not necessarily the top one for a bunch of reasons. Any of these are fine, really, but look what I googled: rectangle overlap JS. That's how you Google. Again, I'm sorry that I'm explaining how to Google, but it's really important. It's the most important part of being a dev, and it really honestly bears repeating so much. Okay, I'm then going to create a little utils class, utils file that has intersect in rectangle intersect. Rectangle intersects, rectangles intersect. Let's say that. So it's a better name. We're going to say rectangle A. rectangle B. So then in here, blocks dot for each block rectangles intersect block, and this ball is a rectangle, so we're going to pass in the block and we're going to pass in this, and what we want to do, if rectangles intersect, then console log the ball has intersected with a block. If rectangles intersect, block this. Now, let's try it. I'm getting nothing in the console, even though I would hope to see the ball has intersected with the block. I'm also getting no errors, which, to be honest, surprises me. But we've got block and we've got this. They're both pretty much the same thing. They've got position, X, Y, they've got width and height. In utils, we went to Google, we went to Stack Overflow, we copy and pasted this. This is the downside of blindly copying and pasting from Stack Overflow or anywhere. This is assuming that your rectangles have properties left, right, top, and bottom, which actually would be appropriate for kind of rectangles in a DOM, because they kind of do have those. So instead of left is basically X, the number of pixels from the left of the screen. So we're going to have position.x. Right is then left plus width. So we're going to have position.x plus rect a.width and rect b.width. Top again is position.y, it's the number of pixels from the top, and bottom is going to be position.y plus height. b.height. Okay. Again, if you're ahead of me, if you're following along, if you're kind of building out your own classes and stuff like that, add getters. So if I might be talking to no one here, but if you kind of followed my suggestion earlier, if you're doing your own thing and you have square as the super class, so those of you who aren't following, this is going to sound slightly weird. If you have square as your super class that block, ball, and paddle all are inheriting from, add getters for left, right, top, and bottom, which return position x plus width. If you're halfway there and you're doing that, the syntax is like this. So top would be return this dot position dot y. Depending on time, we can go through later on and kind of refactor this if we want to, but that is what you probably want to do, to be honest. I don't, if this was a real thing that I was building, I wouldn't do it like this, but for beginners, it was easy to explain at the time. Do we get some intersection logs? We do. Lovely stuff. Okay. Now, two things. We want to remove the block that we've just hit. And what's the other thing? We want to bounce the ball. So inside ball, if rectangles intersect, block and this. We want to bounce off block. This dot bounce off block. We pass in the block. We don't need to pass in this because we have this inside this method. So the way that I can kind of think of it is, no, I to be honest, it's hard, isn't it? I don't really know, but I'm going to make it up. So I'm going to look at the kind of difference between the x and the y values of this and the block that it's just hit, and compare those and use those two numbers to determine if it's sort of further away, if it's underneath it or on top of it or on the side, something along those lines. But bear with me because it might be very wrong. So x difference is going to be math.abs. This gives you an absolute value. Let's hover over it. Shows the absolute value of a number. So the absolute value of -5 is 5. We want the biggest difference, so we don't care if it's -10 and 5. The biggest difference there for us is -10, and so we just want 10 and 5. We want to know the differences. So this dot, oh, yeah, it's going to be weird, isn't it? It's not really going to work, but never mind. Let's see what it does. This position, x and minus block dot position dot x. We then want the same for y. It's really not going to work because this, it's the top left value, isn't it? Oh, but let's see what it does. It might be kind of good enough for now. We want to return, actually no, let's not return anything. Let's just keep it all in here. Let's have reflection amounts. This is going to be an object with x and y. For x, we want it to be -1, so we're going to flip the x value. If, and again, this is where it's going to be some trial and error, if the x difference is greater than y difference, then we want to flip it. If the y difference is greater than x difference, then we want to flip the y. So beginners, we're going to use something called a ternary. Those of you who aren't beginners, we're going to use something called a ternary. So if x difference is greater than y difference, so this is like an if statement. If this is true, use this, otherwise use the thing after the colon. So if x difference is greater than y difference, then flip the speed. Otherwise, multiply it by 1. So we're gonna set it to 1, this kind of reflection amount. If y difference is greater than x difference, then flip y instead, or as well. That would never work. This dot speed dot x multiplied by reflection amounts dot x. This dot speed dot y multiplied by reflection amounts dot y. What's it going to do? Anyone have any ideas? Is it going to just fail miserably? Oh my goodness. Well, that looks good. It certainly, oh, that didn't look good. Yeah, it's not, I did not expect it to be perfect at all, but it's a lot better than I thought it was going to be. It's going to be interesting to know what it does when it goes up the side. Well, there we go. That's good. Okay, so this bounce off block. Then we also want to destroy the block. Now, there is a bunch of ways we can do this. There are a bunch of ways we can do this. What's going to be kind of the neatest way to do it? Let us blocks for each block. Okay. We are going to have a method on block called destroy. Destroy, and actually it's just going to say this dot destroyed equals true. We're just going to add destroyed. We're going to add a new property onto a block, and we're going to say destroyed is true. So if we intersect, then bounce off it and call block.destroy. So that's not actually going to do anything yet. We're just now, hopefully, going to have a destroyed equals true property on our blocks. Now, in our update, we have our ball.update function. After our ball.update function, we can say blocks. What is? Oh, all of this is just feeling more and more hacky, but at least it's kind of the path of least resistance. Okay, so we're going to change our blocks constant variable to a let, because we're going to set blocks again. So our ball has just updated and it has just set a block to be destroyed. We're then going to say blocks equals blocks, but without any destroyed blocks. So that's what we want to do. Obviously that's not going to work, but blocks equals blocks.filter. Again, beginners, this is probably going to be kind of a bit much, but those of you with a bit more experience, you should be familiar with filter. Filter takes an array, and for each element in that array, we have a function that determines if we want to keep the element or reject the element. So we're filtering out particular elements. So we have a function that's going to return true or false. For our case, for each block, we want to return block.destroyed, actually the opposite of that, so this is going to be slightly confusing. Again, if you've got experience, there's a neater way to do this. If you don't have experience, again, we're going to use a ternary again. If our block is destroyed, we want this function to return false. Otherwise, we want to return true because we want to keep that block around. If we return false from this function, this block will no longer be in this array of blocks, and therefore when we draw it again it won't be there. When we pass it through to update to ball again, it won't be there. So this should work. There is a neater way if you're following along and doing your own thing. It's not hugely neater, but whatever. Okay. Wow, look at that. It's like I'm back in the arcades. I never really went to arcades. Let's see what it does. Oh my goodness. Okay, weird. There's weird stuff going on. But I kind of like it. Yeah, there's something seriously is not right, but never mind. Okay, we want to bounce off the paddle now. Oh, okay, well, it doesn't work. Next, we're going to do that. I guess we can do that with the ball. Maybe we want to update the paddle first, or update the paddle, then update the ball with its new position, and then if we've just moved over there, we'll intersect with the paddle. I'm going to do pretty much the same thing. So I'm going to pass the paddle through to ball.update. So it's now receiving blocks and paddle. Check for paddle collision. Paddle. This dot check for paddle collision. Pass the paddle. Okay. If we're going to do the same thing, rectangles intersect, paddle and this. Console.log, bounce of paddle. And what we can do initially, we want to flip the y, so this dot speed dot y multiplied by -1, so it gives us the opposite, the inverse, the negative, whatever. Oh god. Oh, I can use my keys. There we go. Bounce off paddle. Bounce off paddle. Oh my goodness, it's a real game. Okay. Another thing that Arkanoid does to add a bit of strategy, the angle at which the ball bounces off the paddle is different depending on where the ball hits the paddle. Should we do that? It's only 7 minutes past 7, so I think we should do that. So I wouldn't mind drawing somehow, but never mind. We've got our paddle like this. If our ball hits in the middle, it pretty much goes straight up. Maybe it doesn't go exactly straight up. If we hit on the edge, it goes at quite an acute angle over to the left, and then anywhere in between, it's kind of a gradual difference. Let's give it a go. So again, we kind of want the X difference, but this time we definitely want the X difference of the center points, whereas with the blocks, who cares? We're using the top left positions. So we're going to have this center X is this dot position dot X plus this dot width divided by 2. Paddle center X is paddle dot position dot X plus this dot paddle dot width divided by 2. We then difference is going to be this center X minus paddle center X. I'm going to log out the difference. Sorry, I'm getting a phone call. Okay. So off with my keys. 0. was that true? Did I get it? I got it pretty good. I mean, oh wow, I did get it bang in the middle. Oh, that's funky. We don't want that to happen, but we'll fix that later on. Okay. It's, to me, it looks kind of wrong. Okay, -6 was sort of on the left, -12 was on the left. Yeah, it looks kind of right. And this is why making games is hard, because you have to play your game to test stuff. Yeah, I think it looks kind of right. So we've got about -12 either way. Oh, 14. So we've got like 14 pixels. Does that sound about right? How wide is the paddle? The paddle is 30 wide, so there's, I guess, 15 pixels either side. Okay. So then we want to do something like new x speed is going to be the difference. So remember that was 0 right down the middle to 15. I don't know. So when we hit it at 15, let's say it's going at 3 pixels a second, so that means difference divided by 3. Let's just make it up. And this dot speed dot x equals new speed. I think this is sort of how Arkanoid works. Yeah, not quite. Divided by... Oh, did I just say 3? I meant to divide it by 5. Maybe 3 will actually be good. Okay. Still, I don't know. It feels kind of weird. Yeah, that feels pretty good actually. And then quite a side one, yeah. Okay, it's incredibly primitive. So what? Oh, I've just loaded the whole thing. What you actually want to do, you want to work out kind of what your new angle is and calculate your y and x position, your y and x speeds based on the new angle, whereas our y speed is always 1 or -1. That's always constant, but our x speed is going to be like between -3 and +3, so it's going to be pretty weird. Maybe let's change it down to like 7.5. So if difference can be up to 15 divided by 7.5, that now means it's going to be between 0 and 2 rather than 0 and 15. Let's try again. Yeah, I guess. Okay, so the other thing we want to do. Oh yeah, see, that's not great. That's yeah, I can't be bothered to fix it, but certainly you want to get the angle and then calculate the speed of your x and y. But check for paddle collision. If rectangles intersect, this speed y. What we could do is if we multiply it by a number that's slightly greater than -1, we're going to increase the speed every time. So every time we hit, the game is going to get a bit harder, which is probably how Arkanoid works. It is going to be incredibly tricky to really tell because we have this funky x value going on and incredibly funky kind of block bounces, but yeah, now it's gone slower. Is the y increasing? I don't know. In theory it is. That's fine. Again, if we have time, maybe we can improve this. Check for paddle collision. Let's take this out. Handle paddle collision. Just to make it really nice and neat. This dot handle paddle collision. And we need to pass in the paddle. Okay. So we're getting somewhere. Next, we need to I guess lose the game when we go down here. That's really actually the last thing that we need to do to make it a game. Right now, it's not a very good game, but also right now, it's not a game because there's no way to win. Actually, that's another thing we need to do. Say, well done, you won. Once you destroy all of the blocks. And also, there's nowhere to lose. You need those things for it to really be a game. Otherwise, it's just like a thing that does stuff, and there's no real kind of motivation. I can just play it without touching anything. So, how do we do that? What are we doing first? We're doing game over. So, the ball, I'm going to regret doing this, aren't I? Because I'm just going to lose all the time. If the ball goes here, so we're gonna take that out. If this dot position dot y is greater than the height of the canvas, yeah, okay, fine, minus height, then game over. Now we're in the ball. Really what we want is a kind of a function in like index or something like that. Okay, and now I can tell that the y speed is getting faster every time because that's bouncing around like mad, isn't it? So we want a game over function in index. It's getting kind of funky now. And we want to call that from ball. What we can do, we can pass a reference to a function in with the constructor. So game over, we can then like assign it this dot game over equals whatever was passed in here as game over. It's going to be a function. So we can call this dot game over. Now I expect, reloaded the wrong page. I just want to reload that. That allows me to have a drink. Good. I don't think I finished that sentence, but we expect an error. We aren't passing anything in to game over from index, so let's go down here. And we can pass a function like this. I'm not going to do that. I'm going to... whatever, I'm just going to declare it here, game over. And we're going to pass a reference to game over. This is a function. We can, I don't know, document.body. inner HTML is H1 game over H1. It's going to be incredibly dumb and incredibly bad. But let's see what it looks like. There we go. So you can render text inside the canvas. Again, maybe we can do that later. Right now, I don't know if I can necessarily be bothered because it's a bit more of a faff. Is there any way? Is there any other way we can do it? We can do it in app. I can't remember what CSS we're applying to that app width, max width padding. Okay, yeah, let's put it in app instead. App document dot query app dot inner HTML is game over. Reload our page. At least it's slightly more centered. So later on we can get it rendering in the canvas. So we keep those buttons there. You can press A to restart the game, something like that. But for now, we are showing that you've lost, and that's good enough for me. So I guess now there are a bunch of different ways we can go. I've said about 50 times that maybe that's something we can do if we have time. I would say now we kind of have time. Rather than actually, you know what? Let's do U1. It's going to be super simple. U1. U1. Got to be in all caps, hasn't it? U1. Update filter. So after we've filtered out all of our destroyed blocks, if blocks.length, blocks is an array of objects. If we have no more blocks in our array, call U1, and then in fact we return early from this function, stop executing this function, don't draw anything after it, don't request animation frame after it. Now it's going to be, I mean, I'm never going to win, am I? Because I've got game over. Just trust me that that'll probably work. Yeah, I'm not going to be able to test that at all. If we make the paddle very big, yeah, let's make the paddle very big. Oh, let's make the paddle very big and start in the middle. Okay, so starting position X minus half width, this dot width divided by 2. Good, you can see we're now starting in the middle. Now the width, 290, make it a very big paddle. And fingers crossed, yeah, that's going to be, oh, yeah, it's really not going to like that at all, but eventually, I could sort of do something to fix that, but I'm not going to, because it's fine. We'll get there eventually. Come on, little ball. Oh, that was a good one. It's does anyone know John Conway's Game of Life? It's like a really terrible version of that, and also really, really not. There we go. You won. The ball eventually hit all of the blocks, and we got the U1 message. Okay, great. So that's basically it. I'll maybe make each row a slightly different color, something along those lines. Each row and each column, I don't know, something like that. But in the chat, either ask, I don't know, questions to explain parts again. However, this is recording and I'll upload it somewhere, so you can watch again. Or for new features to add, or things that I said earlier that we can do at a later date, and I've forgotten about them now. So add those in the chat while I'm making each row a different color. So in index, we have our y value, which goes from 1, 2, 3, 4, 5, or to 4. In fact, let's have 5 rows. So 1, 2, 5, and then it stops. So 1, 2, 3, 4, 5 we're going to have. Block color is, so we're going to use something, again, for beginners, probably haven't encountered it. Going to use the Modulo Operator, which basically tells us the remainder once a number is divided into another number. So we're going to have y modulo 2. If y modulo 2 is 0, I think this is how we're going to do it. We're going to have colors dot dark. Otherwise, we're going to have colors dot light. And then we're going to pass in the block color. So every row, we're going to calculate a different block color. Let's see what that does. It looks dreadful, but darkest. How did Game Boy artists get anything out of the Game Boy? What they did do, they used a technique called dithering, really. So you'd have, it would all be either this color or this color, but you would have lots of little pixels to make it look darker, or fewer pixels but still some there to make it look lighter. Let's even see what Arkanoid on Game Boy looked like. Hey, it's not too different, is it? It's not too different. It's quite different. Oh, I said we'd draw the ball as a ball, so we can do that. Yeah, we can. Oh, that. See, it's not far off. I mean, it probably works and bounces predictably, which is far more important than how it looks. But it's doing the job, isn't it? Okay, I said we would draw the ball as a ball. So luckily, this position and width and height and all of that stuff, that can stay the same. We're still going to use it as a square or as a rectangle with the intersections and the bouncing and all of that stuff. But we can just, in our draw function, instead of fill rect, can anyone remember how to do it? And I am asking that because I can't. It's arc. There we go, it's arc. Okay, begin path, arc, fill. Every time. In ball. Okay. Now this is going to be interesting. So arc, this is going to be the center of our circle, which is going to be position X, position Y, plus half width and half height. So center is going to be X, this dot position dot X plus this dot width divided by 2, and do the same for y, height, and so center dot x, center dot y, no, y. Let's see what that does. I think it's going to be really big. That's a very big circle, but okay, good, it moves around. Now this is the radius, which is not the diameter, which would kind of be width or height, because it's, luckily we're dealing with a square. So it's going to be, I've lost it now, it's going to be this dot width divided by 2. That's going to be our radius. And we've got a ball. Lovely stuff. It looks pretty pixelated because it is. This is 300 by 200. I've zoomed it all in, so it doesn't look great. Now, there might be some way to change how the canvas is displaying, like removing the anti-aliasing, and I feel like it's a CSS thing. Font smoothing, anti-aliasing. Let's Google JS canvas or just web canvas, because it's not really necessarily JS, it's kind of website. Web canvas anti-aliasing. So anti-aliasing is making it. There we go. Anti-aliasing cannot be turned off. And is controlled by the browser. Can I turn off anti-aliasing? Image smoothing enabled applies to pattern fills and draw image. Image smoothing enabled. You may translate canvas by half pixel distance. Okay, who knows what they mean, but let's try it. So, context, image smoothing enabled, false. Let's try that. So, that's in draw shapes. Context.image smoothing enabled, false. That did nothing. What was the other one? Translate 0.5, 0.5. So this is going to move everything by half a pixel on the x-axis and half a pixel on the y-axis. Michael Sutton's come along with device pixel ratio. We've gone kind of the other way. We've gone kind of blurry. So I think ultimately you'd have to do some slightly interesting fudging about to get it to display really nicely. Device pixel ratio of window interface returns the ratio of the resolution of physical pixels. Change to 1 on Retina. Okay, yeah. Okay, so that actually changes the size of the canvas. So I don't want to do, or at least that snippet. So I don't really want to do that. But it doesn't really matter. Let's try, or let's do something else. Let's add some more functionality to this. What could we do? We could do something like, we could add something that's a bit more fun. So when the ball hits a block, we currently call destroyed, and we immediately get rid of it. What we could do is not really animation as such, but let's do something a bit more fun. So block.destroy. I'm actually going to say block.hit. And inside block.hit, we're going to say this.hit equals true. And then we're going to say this.speed.y is +1. We want the block to move down. I don't know, let's say 2 or something slightly faster. It's going to move down when it is hit. So what we then want to do, we don't want to check the collisions against any blocks which are currently hit. So what we could do, blocks which are not hit is going to be much like this. We're going to have blocks.filter block. For each block we want to say blocks.hit, and here's the neater version that I didn't do earlier, but I'm going to do for brevity now. If you put an exclamation mark in front of a boolean is true or false, put an exclamation mark in front of it, it kind of flips it. So not, that's what exclamation mark means. So not true is false, not false is true. So we want to keep all of the blocks which are not hit. We're going to pass that through to update. But blocks which are hit, I hit, blocks.filter block.hit, arrow. We are going to, actually that should kind of be after, but never mind. Blocks.forEach block.update, and then blocks for each draw. Yeah, okay, cool. That should still work. Blocks which are hit. For each block which has been hit, we're going to update that, so that needs to start moving down. Who knows? Nope. Blocks which are not hit, I suspect blocks. I suspect this is empty. I'm going to log it out to see. Blocks which are not hit. Yes, that is empty. And it's still empty. What am I doing wrong? Not hit. Oh! Okay. Yeah, okay. block.hit is a Boolean value, right? It's true or false. That's what I am now thinking it is, because in block we say this.hit equals true when we call the method. But actually, before we say this.hit equals true, this.hit is actually this function. So hit by ball or falling down or something like that, that's going to be our Boolean. Block hit by ball, block hit by ball. Oh, it's good fun, isn't it? So we don't want to do any of that stuff. We don't even want the X on the blocks. I'll leave the rest as it is. However, actually, if this dot position dot y is greater than context dot canvas dot height, so if we've gone down the below the bottom of the canvas, this dot destroyed equals true. True. So if it goes down below the bottom of the canvas, we're going to set destroyed to true, which we've still got that code over here. So we should still remove it from the drawing, remove it from any calculations we're doing. Oh dear, never mind. Okay, cool. Again, that looked fine, but what we could do is in block, we could have speed y plus math.random, and the x value, this dot speed dot x, is math.random minus 0.5. Math.random gives you a random number, a random kind of decimal place number between 0 and 1. So for our y speed, all the blocks that we hit, conveniently the first thing this ball does without me doing anything is hit 2 blocks at exactly the same time. So they both fall with identical speeds. That looks very boring. So now it's going to, each block is going to fall at somewhere between 2 and 3, so between 0 and 1, and it was starting at 2, so somewhere between 2 and 3, that's going to be the y speed. Here, somewhere between 0 and 1, minus 0.5. So that results in somewhere between minus 0.5 and plus 0.5. So it's gonna go either slightly left or slightly right. Let's give it a go. Oh, I'm not changing the x, the x value. Oh, it's a bit funky because they overlap, but never mind. It looks fine. It looks it looks dreadful, doesn't it? But it's a bit more fun, and the game is really hard now, because the paddle should definitely be faster. So this speed, I'm gonna kind of have like this dot base speed is gonna be 2, and where we've got all these 1s, we're going to say this dot base speed instead of changing 1 4 times, and then if I'm not happy with the 2 that I just chose, I have to change 2 4 times, I have to change it 4 times. Use variables wherever possible, and then you just have to change 1 value. Oh, it looks. Oh my goodness. The bouncing off the blocks really sort of throws you. We can fix that if you want, or if anyone has any. Actually, I'll be honest. I probably can't fix that in the next 15 minutes, but I'm very willing to try. I will try that if no one has any other suggestions. Or do you all want to go and eat your dinner? I do. Okay, I'm hearing nothing, I'm seeing nothing. So let's try to fix the block bouncing. How? Okay, we've got our ball. Yeah, so what we do want to do is not use the top left. Now, I want to use the center. I briefly showed it earlier, and I'm going to add a getter to block and ball so that we can just a bit more easily get the center. A getter is kind of like a function that you don't have to invoke. It doesn't receive any arguments. It calculates a value when every time you get the value. That's a simplified explanation. X is going to be this dot position dot x plus this dot width divided by 2. Y is going to be this dot position dot y plus this dot height divided by 2. Block. And again, if we inherited from square, I wouldn't have to copy and paste this, but I also don't have to do this anymore. I can use this dot center. So now on ball, center. Who knows? No. It's really very much the opposite of what I wanted. That was okay. That was not. Okay, I think it's... Yeah, this is not very good. I think this is just not how it should work at all. I think we need to take into account the width and height of both of these. I certainly won't be able to figure it out in the next 15 minutes, so I can't really be bothered to even try. But is anyone good at maths out there? Center X is... If center X of the ball is less than center X of the... It's not even the center, we want the edges, don't we? We want the edges. If the rightmost edge of the ball is greater than the leftmost edge of the block, then we're kind of above or below it. Oof. Okay, let's try that. What did I just say? Let's comment that out so we can come back to it. Ball right. So this dot center, actually it doesn't matter, this dot position dot x plus this dot width, That's the rightmost edge of the ball. Block left, block dot position dot x. If ball right is greater than block left, then we are above or below it, because we're like overlapping on the x value. So reflection amounts. So we're going to set those to 1, but reflection amounts dot y is going to be -1. We then want to do the same for kind of right and left the opposite way. So ball right, let's do block right, block left, ball left, block dot position, ball dot position. If block right is greater than ball left, then again, yeah, I think that works, this dot position. I think we want to reflect in the y. Oh, this is probably not going to work. Let's try it out so far. So our x isn't going to bounce, but hopefully our y does. No. Oh, it looks cool though. It was much better before, but it does look cool. Yeah, I can't be bothered. It's good enough. I remember I said it would be good practice for you to go ahead and improve the game. There's an improvement for you. Make the bouncing less completely insane. Oh, even that. Yeah, that's not right, is it? Well, I think I'm calling it a day there, because I don't want to get bogged down into calculating that. And I see nothing in the chat. I'm hearing nothing. So I will leave it there. No, if no one has any questions, thank you for joining me on week 2. Hopefully you learned something. Feel free to fork this version and make your own. Display it differently, add a border, kind of stick in the canvas. It's good practice. Although in practice you don't really use the canvas very often, so don't worry too much. Actually, one note on that: in practice, I use a library called Pixie. It is specifically just for rendering, so it has a bunch of helpers to render kind of rounded corners better, and I don't know why this background thing isn't showing up, but gallery, they're all far too intense. Let's do demos advanced. Here's a scratch card. This is what I used to do for a living. You can do funky stuff like this, and it makes it easier. It's still not super easy, but this sort of thing would be ridiculously hard to do with direct access to the canvas, and this is much more performant than, I mean, again, it depends what you're doing on the canvas, but it's probably going to be much more performant than whatever you're doing. Let the experts handle it for you. It's also not really using the canvas anymore, it's using WebGL. But if you do want to make browser-based games, I heartily recommend using Pixie as your renderer. If you want a bit more of a fully fledged experience, I've forgotten what it's called. Phaser. Phaser is so here it is called HTML game framework, whereas Pixie was just a renderer. It has WebGL and Canvas, so that basically is Pixie. On top of Pixie, it makes loading files easier for you. It has some physics stuff built in, rendering sprites and animating them. It's got nice particle effects. All of this is built in. Sound input. It deals with button presses and all of that a little bit nicer than doing it directly with the browser. Ultimately, especially Phaser is built on all of this stuff that we've been doing. It's object-oriented code. You're going to create a sprite, and then you're going to be moving it in some kind of update loop. And you're going to be saying, does it intersect with another sprite, and then destroying it, all sorts of things. So it's pretty much the same. It's just setting up a lot of things to make your life easier. And yeah, Phaser's pretty good. Cool. Okay, let's leave it there.